It's our 1-year anniversary episode, and we're going to be talking with Reyk Floeter about the new OpenBSD web server, why it was created, and where it's going. After that, we'll be showing you the ins and outs of DragonFly's Hammer FS. Fun. And of course, we'll have answers to viewer-submitted questions and the latest headlines on a very special BSD Now this week, the place to be. SD, my friends. BSD Now, episode 53. It's Hammer Time, recorded September 3rd, 2014. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
We're glad to have you guys with us today. We got an exciting show coming at you. We're looking forward to it, so let's get right into our headlines. So first up, FreeBSD news. It looks like the Foundation has announced a new project to do some IPsec work.
Yes, trying to, well, now that 10 gigabit and 40 gigabit interfaces are becoming more common, the stack needs a little work in order to be able to handle that.
Very cool, very cool. It looks like they're working with Netgate on this to make it, to improve the speed on it with bandwidth in the 10 to 40 gigabit per second range. So
yeah, specifically using newer AES ciphers like AES CTR and AES GCM, and implementing AES-NI, the processor offload, to do the encryption.
Yep.
Since if you're going to encrypt 40 gigabits per second of traffic, you're going to need some help from the processor.
Definitely. Looks like they're going to be bringing some code in from OpenBSD to help accomplish this as well.
Yep.
So that's going to be neat to see. And it looks like they're going to try and have this in pfSense 2.2. It's expected to be completed at the end of this month. So
yeah,
about 3-4 weeks there, and here we go.
Nice and aggressive. It's nice to see stuff.
Definitely. It's always nice to hear about that and go, it'll be done in 3 weeks.
Yep. Well,
cool.
John Mark, I think, is working on this almost full time, so that'll be interesting.
Fantastic. Well, that'll be great to have.
Yeah, so based on John Mark's existing stuff, when he did AES-NI stuff for the Geli disk encryption, a modern 64-bit x86 CPU, one core can process about 1 gigabyte per second of traffic.
Wow.
So obviously that's 8 gigabits per second per core. So it won't take very many cores to be able to saturate your 40 gigabit. And so, with most of these higher end machines, if you're going to be running 40 gigabits through it, you're probably going to have 16 or 24 CPU cores.
You'll have plenty of cores to feed that.
You won't be maxing out your system at all to do that.
Oh, fantastic. Well, we'll look forward to seeing that hit base. So let's see, is that going to be in, I guess, current first?
Yeah, that'll go into FreeBSD current. And
that's not going to make it into 10.1 though, right? That's
no, it's way
10.2.
Yeah, it's 10 stable is in slush, or it's frozen.
Yeah, they're in
already.
slush now, I think, or they're freezing it this week.
Yeah, they're freezing it in the next couple of days anyway. So there'll be no new features going into 10.1.
Okay. Well, cool. So for those on the release cycle, looking forward in 10.2 coming soon, sometime hopefully mid next year. Okay, excellent. So next up, news. We have some NetBSD news. It looks like at the Shinmain Open Source Conference, the Japanese NetBSD Users Group held a NetBSD booth at the Open Source Conference 2014, Shinmain, at August 23rd. So one of the developers has gathered a bunch of pictures from the event and wrote a fairly lengthy summary. I don't know if do you have the pictures on the screen we can show folks?
I'm looking for some pictures. All I found is Japanese writing. Here are some pictures. Yeah.
It says
yes, there's lots of pictures. I just had to find them.
Okay. So, of course, they had NetBSD running on all kinds of different devices, including, of course, a Raspberry Pi with an LCD display. We got an HP 9000/425E, which they're also demoing the new ARC OFI audio driver. So, okay, very cool. Sony NWS 5000 and the NetBSD i386 is a serial console. They have a Sharp NetWalker, an XM6i, which is an X680X0 emulator running NetBSD X68K and Human 68K on Windows. And then they also had a Sun Java station, which they said didn't boot because they had some problems with the server in particular. But it sounds like they got quite a collection of exotic items there to show off.
Quite a few different... all the weird hardware that people like to play with. and all of it runs
So we have a comment here.
NetBSD.
Of course, some of the visitors said NetBSD had the most chaotic booth at the conference. Well, with that much stuff they brought, I mean, it was probably pretty crowded there. So that is cool, though. So again, check that out if you're interested in any of those devices there or want to see what NetBSD can run on. Okay, so next up we have pfSense news. I guess pfSense has issued a new release, 2.1.5. So this, of course, is a new version in the 2.1 branch. Notable in this release is it's mostly security focused, so it includes 3 web UI fixes
and the OpenSSL
of course, the most
patch.
recent OpenSSL patch, which we have a note here, FreeBSD is still not patched in release after nearly a month. You don't have any inside info on why that's
tried to
taking so long,
investigate a bit and didn't hear anything back. I'm gonna have to poke harder.
Yeah, I have not heard of people, anybody.
I've had, when I started asking, other people started asking, but I haven't heard anything yet.
Okay, well, we'll keep an eye out.
I have
for that
quite a few
course,
different fixes here dealing with the DHCP server and using CARP and IP aliases properly, and lots of other interesting little fixes to make pfSense that much better.
Of course, so you need to update to this right away. So you can check out the link, of course, in the show notes if you want to get the full list of fixes there. And definitely get your systems upgraded right away. I mean, just for the OpenSSL fix alone, that sounds like a good deal. Cool. Okay, well, next up we have a video, actually, about system science and FreeBSD. So our friend George Neville Neal, or GNN, also just gave a presentation at Microsoft Research, of all places. How cool is that? And
systems science and FreeBSD.
Yeah, that's pretty slick. It's mainly about using FreeBSD as a platform for research inside and outside of universities. So you can watch the video. The talk is going to describe a lot of the OS, features, ports, the developer community documentation, who uses BSD, and much more. So it sounds like a good academic talk if you're interested.
Or even
about
in this
BSD.
case, Microsoft, if you want to build a new technology, it might be easier to build it over here and then bring it to Windows after.
Correct. So George, of course, is famous for writing a lot of books, and he's been around the community for a long time.
Knows the network stack inside out.
Correct. So he's always fun to listen to anytime he's talking about BSD. So yeah, you'll want to check that out if you want to. Yes, very good speaker. So highly recommended. Do you know how long the runtime is on the video?
Just under an hour.
Just under an hour. So, okay. Well, that would be fantastic. Load that up. That may be another good podcast one to listen to on the way into work next time. Fantastic. Okay. So, of course, we want to mention the sponsor this week, which is Tarsnap. And the URL for that, tarsnap.com/BSD Now.
Everybody needs backups.
Yes. And you need backups that are encrypted. Yeah. I mean, you don't... I mean, come on. Look at the news that's happened this week, or stuff gets put in the cloud.
I thought I deleted that. It's like, oh, they hacked my backups.
Yeah.
Should have had better backups.
You don't want to put up with that crap. You need better backups. You need a backup where you can trust that the key you have is the only one that will allow access.
Even the service you're using can't play with your files.
That's correct. Just so if a machine gets rooted somewhere, you're not necessarily compromised. So anyway, yes, you want to take a look at Tarsnap. Again, open source clients for pretty much everything under the sun out there. So you can find a client that'll even run in Cygwin on Windows, and then, of course, Linux and everything in between. So take a look. Super cheap to get started, and your backups will be encrypted before it even leaves your box. So very, very important. But again, tarsnap.com/BSD Now, and let them know that we sent you. And we're joined now by Reyk Floeter, the OpenBSD project, who's here to talk to us a little bit about OpenBSD's HTTP daemon, of course. But before we do that, of course, welcome to the show. Glad to have you with us this week.
Thank you for coming.
Yeah, thanks.
So first up, tell us your background. How did you first get your feet wet with BSD and get into this whole community?
Well, I got into OpenBSD specifically because I was using it for networking and security, but actually I really got into it because of the wireless stuff I was doing. You remember the days when we didn't have a free driver for the Zeros wireless chipsets in BSD. So I started writing one for Linux, an open source driver. And then I got in contact with the OpenBSD folks, and they asked me, can you do this for OpenBSD, write a driver without a binary blob? And that's actually how I got into OpenBSD, and then I started even using it more. Before I was a little bit Linux minded, by writing the OpenBSD ATH5K driver, or the OpenHell. And I stopped using Linux actually after that. That was
enough, huh?
2004, so it's almost 10 years ago.
So
Nice.
I guess, how did you first become an OpenBSD developer? Like, when did you get your commit bit or account or whatever they call it?
When CEO invited me to work on this Aceros driver, and actually when I was able to make an SSH connection with the Aceros driver, the OpenHAL said, well, it works, and then he gave me commit access and said, well, then commit it to OpenBSD. So some people get their access earlier, but I basically had to prove that my driver is working, and then I got my account.
Cool. So that was the test, and you passed apparently. So.
Yes.
Cool. So on to our main topic, though. So what's the backstory of this new HTTPD? How did it get started, and why do we need it?
Well, the story was that OpenBSD was not so happy about the ancient Apache 1.3 that we had in our base system. So Nginx was there, and Nginx is a decent web server. It has a BSD license, so it's just fine. The problem is that we have a few ideas about how a web server should work in OpenBSD. For example, our Apache web server did use a change root by default. That was an OpenBSD patch that was never accepted upstream. And we did the same for Nginx. We also adjusted a few other things in Nginx that some of them maybe got back into upstream, others not. But we figured out that it was really hard to maintain Nginx in our base system, because from time to time, the maintainers like Robot, for example, imported an upgrade of a newer Nginx version into OpenBSD, and then we had to apply our patches on top of it. And Nginx is written in a special dialect of C, so it's really not fitting in our base system where we have like this BSD, KNF style. So Nginx is a little bit different. I don't say it's bad, it's just a very different style of C coding. And it was really hard for us to maintain and to apply some of the standards that we have. And then keeping this patch up to date with newer versions was also hard. This was one reason. So maintaining this in our base system didn't really make sense. So the ports is a better place for it, actually. And the other thing was that the web server and base in OpenBSD's base system is really used for fairly ad hoc and simple things, like serving some statistics pages, static websites, and doing some fast CGI. And Nginx is way too complex for the things we normally use it.
Kind of lighting a candle with a blowtorch.
Yes, yes. So over the years, Nginx got bigger and bigger, more features.
Yeah, I remember when it was small.
And yeah, so now you have a GeoIP module and all these things that we don't really need in Nginx and in OpenBSD's base system. So we try to clean it up, and we try to, for example, Nginx has a bunch of like memory allocators, actually. We learned from the OpenSSL case when we started LibreSSL that one of the problems of OpenSSL is or was in OpenBSD that it used its own memory allocator, where it was basically hiding some operations, and it was a mitigation against our mitigation techniques in our libc malloc, right? So if you run your own memory allocator and you never free the memory, it's never returned to libc, and then you cannot detect various things that we do in our libc malloc. And Nginx is doing similar things. There are all kinds of memory allocators to improve the performance. Nginx re-implements basic libc functions basically just to be faster, and this is a good point for web applications, for some large scaled websites, but it doesn't really match what we want to have in OpenBSD. So
especially in the base system.
Yes, yes. So how did HTTP get started? Well, at the OpenBSD hackathon in Ljubljana in Slovenia, I was one afternoon I was joking and I said, well, I can take RelayD and turn it into a web server. And some people didn't really take me serious, and they said, well, don't write another web server.
Right, writing a whole one from scratch is not what you're after, right?
So, but a few hours later, it's the same day, I had something basic running. I took the RelayD source code, ripped out a lot of the stuff that is in RelayD, but there's already some HTTP handling and all this daemon infrastructure from RelayD. So I had a basic web server running at the same day, and somehow Bob Beck, we already had a beer at this point, convinced me to commit this web server. And since it was not enabled in the tree, it didn't harm anything. So Theo and Bob got me to commit this web server. And this was how it started. Next day, I woke up and said, oh, what happened? I committed a web server last night. So it was really how it started. Yeah.
So I guess you, RelayD already had a lot of the infrastructure like HTTP parsing and the daemon stuff, so you already had most of a web server just laying around?
Yes. The RelayD is kind of a, it even has more features, and it's an HTTP engine already, but it missed the file handling, of course,
so
and some logging and stuff.
Mostly you had to strip RelayD down to make it only a web server.
Yes, kind of, yes. And then add the ability to read local files instead of just serving between two network connections.
So Nginx was removed from current already, so I guess that's the end of Nginx. You just get it from ports if you still need it?
Yes, I mean, it took 14 days to get the web server to a state where we were like kind of happy.
So that was a lot sooner than I expected.
Yeah, well, Theo was kind of encouraging me to write it quickly. So we have a working version in 5.6, but it's not really production ready, but it's in the goal was to have something in 5.6. 5.6 comes with Nginx and HTTPD, but in current, they kind of rushed and removed Nginx, which is okay. Nginx is in ports, you can still use it. I don't have any strong feelings against Nginx, right? It's just from a security perspective, we can do all the fancy things that we want to do that are specific to OpenBSD in HTTP.
Without having to have that separate patch that you have to try to track.
Yes, absolutely. And it really helps also to improve RelayD, because the many changes that we do in HTTPD can be merged back to RelayD. Especially the proper HTTP handling the protocol. So some more changes are coming up for RelayD. So it's a back and forth. So it's actually a big win-win for both sub-projects, actually.
Well, since you mentioned it, as the code's obviously partially at least based on RelayD, what are some of the key features that maybe they share?
Well, the key feature, the one thing is the daemon infrastructure. So it's privilege separated. It's not just like starting and then forking a big process that gets change routed. It's so it has the ability to run multiple things in different processes. At the moment, it's a pre-forked model, kind of fixed worker model. But you can, for example, reload the configuration at runtime without problems. But the web server is running in a change root by default, so you cannot run it without a change root, actually. The different things are really more like technically internal, how the code is written from the configuration grammar parser and the privsep implementation and the ability to reload and all this. So this is the code that is shared between RelayD and HTTPD. Some new features are in HTTPD. For example, the goal was to be able to reserve static files and to do fast CGI. And so since we already had slow CGI, our own fast CGI to CGI wrapper that was written by Florian, one of our developers, he took his slow CGI code basically and turned it into a fast CGI implementation for HTTPD. So we have another synergy here. And so HTTPD can be used to run WordPress, for example, or things like that using fast CGI. And this is, of course, not in RelayD. RelayD doesn't need fast CGI or something like that.
So how much work was it to extend the PF style config syntax to be able to configure a web server?
The configuration syntax of HTTPD is using the parser, parse.y, and the configuration parser and all that, something we have in almost all the daemons, the new daemons in OpenBSD. But the grammar looks different. Okay. The grammar looks a little bit like Nginx, actually, but without the semicolons. I don't see the point for having a semicolon at each end of each line, and a bit simplified. So you can write a basic web server with a very simple configuration, but you have server blocks and location blocks and types. So there are some similarities where they make sense, but it's not just like a one-to-one copy. Right. Some things are different.
Right.
Cool. Well, do you see the possibility of this eventually becoming maybe a competitor to Apache or Nginx?
Well, to Apache, yes, it's not difficult, right? So, but I'm not going to support modules. No shared objects or loaded modules, or I'm not going to add a DL open interface, basically. For Nginx, well, competitor is difficult to say. I mean, for the performance, I don't think so, because HTTPD is not slow, and compared to Apache 2, I think it runs really well. Nginx is just incredibly fast. But if you look at the HTTP parser in Nginx, you know why. It's crazy. They have. I tried to read this code, and I think you can make some lectures at the university or your PhD thesis about the HTTP parser in Nginx. It's insane what they're doing. So if you really need the ultra performance for the local web server, then Nginx is probably better. If you want something that is more secure, and this is an area where OpenBSD is also strong, and then HTTPD can be a serious competitor, actually. Right. And if you have some websites where you don't even measure these tiny differences, then the performance is still very good and good enough.
And it's the OpenBSD HTTPD will have the feature that it won't get bloated like every other web server seems to do. Right? Nginx started out almost as simple as HTTPD and now keeps growing more and more stuff. Whereas I think OpenBSD's HTTPD we can count on to actually stay small and fast.
Yes, absolutely. I do still add features, but I want to add like basic features to get stuff running and to replace it in some existing setups. But I also have to reject some feature requests already and even diffs. So some people are already angry at me because I don't accept their diffs. But there we say it has to stay small, so we reject features. And maybe there's a possibility to add like a socket-based interface to extend it further. But fast CGI is also a very flexible option these days. And if people say, well, but I need, what is the other thing, US CGI or UW CGI, and these different CGI interfaces, then, well, it works well with fast CGI. So I don't need to add 10 different variations of the same thing and all these special modules and so on.
Do you see there is a possibility for a portable version to have that OpenBSD HTTPD come to other operating systems?
Yes, absolutely. So I'm not working on this yet. I think I heard from one person that he started looking at portable. Relady is also in FreeBSD, so
most of the work has already been done.
So yeah, and with HTTP it's even easier because it doesn't have so many OpenBSD specific interfaces. Relady has carb integration and some other things, but with for example, and HTTPD doesn't do that. We don't have a send file interface in OpenBSD, so it's just plain file I/O basically.
Cool. So what are some of the planned future additions, or do you guys have a roadmap with some neat items on it?
Well, at the moment we have a list of features we want to finish, and these are smaller things. So, for example, the virtual host handling has to be improved. At the moment, you cannot define multiple server blocks with the same name, and so these are very like annoying things when you want to configure more complex configurations. So this first has to be fixed. But really major features, it's almost feature complete. So it's hard to say. So we do need HTTP basic authentication. This will come to protect some subdirectories. We also need some access deny kind of rules. This is not available at the moment. So really just basic things. But nothing special that I can think of at the moment.
Have you decided on a name yet?
Isn't HTTPD great? I mean, in OpenBSD we don't really do names. If we have new software, the software is called like the protocol. It's well, you can call it Open HTTPD if you want, but it's probably already used this name. But I know in FreeBSD is different, right? Every subsystem gets a fancy name, and OpenBSD is kind of the opposite. We try to use like very basic names. Sometimes the problem is that the software names are not very unique, but That's the way we
Well,
do it.
you know, Relay D was a lot better than Host APD or whatever it was called before.
Host AD, okay. Some Americans gave me an English lesson. That was an unfortunate name. Yeah.
Cool. Okay. Well, anything else you want to mention about this before we go?
Well, there's a website, BSD Plumbing. It's currently down, but I'm just setting it up, which will cover RelayD and HTTPD, or actually relayd.org. But at the moment it's down because we're moving to HTTPD. Of course, we have to eat our own dog food. And to run the site, I have to implement a few things. But it's very good.
Oh, very cool. Well, we'll have to mention that in a future episode when that comes available, so we can point people to URL. Well, cool. Well, thank you so much for being on the show with us this week.
Thanks for inviting me.
Great. Well, we'll
See you in Sofia.
In just a moment for our next segment. And we're back. And before we go into the news roundup, of course, we want to mention the other sponsor for the show this week, which, again, is IX Systems. And they have some new stuff for us this week. Looks like a photo album that we got shared here of pictures from VMworld.
Yes, and they have pictures of the TrueNAS Z50, the all-flash storage machine. Look at it; it's all pretty, and the logo glows.
Yes,
That
it
is
It
fancy.
is very nice. That's the kind of system you'll put in your data center, and when people come by, they're like,
Yes, that's the one you take the
that?
pictures of.
Yes, to show off how high tech your data center.
Yeah,
looks.
so they had a combined booth with Hitachi's storage people, and so they're showing their high performance NAS and SAN for VM deduplication using the TrueNAS Z50 and the HGST SAS SSDs. And lots of people came by the booth and learned about the crazy all flash super speed ZFS.
Yeah, it's fantastic. Well, it looked like a fun show. Definitely. Well, of course, IX Systems can get one of those for you if you're interested. And we mentioned the URL. It's ixsystems.com/BSD Now. Let them know that we sent you. But, of course, they can build that, or they can build something smaller if you need something down to a FreeNAS Mini to just toss under your desk and use for some local storage. But, of course, these are all powered by the latest and greatest Intel processors. And with the number of BSD people they employ actually on staff, from kernel developers to port developers, etc., they make sure this stuff just works.
Yeah. And of course, you can come out and meet everybody. They're having Meet BSD is November 1st and 2nd in San Jose, California. It's actually hosted at Western Digital's headquarters this year.
Correct.
But yeah, if you go to meetbsd.com there, you can just get all the information. You see it's a hybrid unconference, which is a really neat format. There's a couple of, the regular talk type things, except for a little more interactive, but also a lot of other stuff where instead of just, sitting in a room and listening to technical lectures and so on, there's a lot more interaction. They have speed.
Well, they will make you shut your laptop off,
Exactly.
or like close it up.
Yeah. You don't even use your laptop the whole time you're there. But, they have speed geeking where you get to learn a little bit about a bunch of different things at once so that you can decide, oh, I'm interested in this. I want to go sit with these guys for dinner and learn more about one of those and, get more exposure to things you wouldn't be able to elsewhere. And then they have the Birds of a Feather sessions where, just go into a room with a bunch of people that are really passionate about the same subject you use, whether that's Beehive or ZFS or security appliances or whatever, and get to just talk about that for an hour and then report your findings back to the whole group at the end. It's those are really interesting as well. And I think the biggest thing about Meet BSD was just you get to meet more people and actually talk to them, and it was just, I made a lot more personal relationships there than at the other conferences, even though, you meet lots of people and do stuff. It's just, you have more time to actually.
Well, the whole event.
Actually basically social. It's one giant hallway track rather than, a bunch of talks with 10 minutes of hallway in between. It's, mostly hallway with a couple of talks in between. And, I definitely really, really enjoyed it in 2012 when I went. So
Definitely a good conference. So if you're in the Bay Area or you can get to the Bay Area, I think, what is it,
First and
November
second,
1st is when it starts this year. 1st and 2nd. So try and make it out to meet BSD. It definitely should
and
be
they
a
have
good
some
conference.
good deals on
But,
a group rate for the hotel and everything. So check out the website and
Cool.
hopefully see you there.
Okay, great. Well, cool. Well, let's get into our news roundup for the week then, Alan. So first up, we got some OpenBSD news. So it looks like they got a new RCCTL tool usage. They recently got a new tool for managing /etc/rc.conf.local and current. Somewhat similar to FreeBSD's sysrc tool, so it's going to eliminate the need for you to have to manually edit rc.conf.local to enable or disable services.
It's especially handy with things like Puppet, where you can now have a safe command line way to change the enabled or flags or whatever in your rc.conf and various other files. So they use rcctl and FreeBSD is sysrc, but their rcctl also controls or kind of includes the service command from FreeBSD, which is how you actually start and stop services. So yeah, they combine those into one tool, and that's quite nice.
Oh, that's pretty cool. Definitely. So we have the blog post linked in the show notes here from a BSD Now viewer, actually, that shows some of the typical usage of the new tool to alter the startup services. And this new tool is not going to make it into 5.6, but it will be in 5.7, which is scheduled for next May. So coming soon.
There's a couple features here that I'm going to have to get Devin Teskey to implement in sysrc, I think. There's a status one that will just go through and tell you each daemon and whether it's enabled or not, and a couple things like that.
Well, so you can do some of that with our rc.d scripts. What I found was in FreeBSD, a lot of them just didn't have the capability built into the rc.d script.
Right, well, this one's actually looking at the rc.conf and going through and finding all the ones that are not set to something other than the default and things like that.
Oh, okay, there you go. Yeah, that can definitely be handy. Cool.
Nice work.
Okay, well, next up in the news roundup, some more pfSense news. So we have a mini roundup for a whole bunch of stuff pfSense related. It looks like 5 articles in total. So the first one, though, pretty cool. If you're outside of the U.S., how you could stream Netflix in a non-U.S. country using their smart DNS
to
service.
A Chromecast.
So,
yes.
Oh, very fancy, very fancy. So yeah, that's something you'll want to take a look at if you would like to be able to watch some shows and you're not available in the States. The second post we have is talking about setting up IPv6 in particular if Comcast is your ISP.
Apparently Comcast is already doing a terabit per second of V6, and I think most of that is actually to Netflix.
Oh, there you go. The third article we have a link to features pfSense on Softopedia, a more mainstream tech site, which is pretty slick to see it getting published there.
Awesome graphs that pfSense makes.
Definitely. And then the fourth post we have describes how to filter HTTPS traffic with Squid and pfSense. So if that's something you need to do some filtering, that would be a cool one to refer to. And then the last one we have describes setting up a VPN using the TINC daemon and pfSense.
Yeah,
so
by default,
cool. I guess it's a little lesser known.
You'd use OpenVPN or one of the other VPN software in pfSense, but this one talks about using this other new one. So that's interesting to see more options and compatibility there.
Definitely. So the pfSense HQ website we have linked here too also has a lot of other cool pfSense items. So you'll want to take a look at that. There's a lot of ways you can make your pfSense system do new interesting things that maybe you hadn't considered in the past. Okay, next up, some OpenBSD news. I guess they got a new buffer cache. So
most buffer caches have been, up until now, the OpenBSD one used a standard LRU, or least recently used. So basically, a list of the most recently used buffer. Every time you use a buffer, it goes to the top of the list. And if the buffer is full and it needs to make room to add a new one, it deletes from the bottom. So the ones that were least recently used to make room to add the new one to the top. The problem is that if you have like a cycle where you're going, read this file, this file, this file, and this file, if you're going through that, you can basically, if your cache is only big enough to hold 4 out of the 5 files, you'll never get a hit because the next file will always push the file you're about to get out of the cache. And that's why ZFS uses something different called the ARC, the Adaptive Replacement Cache. But for OpenBSD, they've implemented 2Q, which is an algorithm invented by Johnson and Sasha at, does it say which institution? It's still downloading. Anyway, some research went into this, and they created this 2Q algorithm. So with it, you get different results. He says, reading the paper is the best way to understand exactly what's going on. But he says, summarizing his highlights, the main insight is that in addition to LRU's current working set and previous working set, there's a third working set, the long-term working set. We start by assuming that a buffer is in its current working set, then quickly move it to the previous working set or sets. And then if we need to buffer it again, that's a hint that it's actually a long-term working item. So basically what this does is separate the stuff that's rapidly going through and the stuff that is staying for long-term. And so we make the long-term stuff stickier so that it doesn't keep getting pushed out by, scanning through a directory or something.
Less often things.
Now, it says the code in OpenBSD resembles 2Q, but has some significant differences. So they've kind of done their own thing because, the 2Q here, I think, is a generic algorithm rather than something specific to how OpenBSD was going to use it. So his main priority was ease of implementation. 2Q keeps a history of past buffer addresses to know when a miss was previously in the cache. Buff cache doesn't provide that capability in its current form, and there were some other obstacles as well, and it goes on to describe those. But he says the results in some ad hoc MD5 of some large files that he did as a test, he confirmed the contents of the bin directory remained in cache when they otherwise would not, right? So when he's scanning over a whole directory, normally you get that loop where you keep pushing out the thing that you're going to get to in a couple of more steps. But with the new code, it would actually stay and improve quite a bit. Other interactive responsiveness tests went very well as well. And the primary goal has been to achieve some degree of scan resistance. So, ZFS kind of does something like this for it as well. Is when you want to, if you're going to, say, scan every file in a database, doing that generally is going to just invalidate your entire cache because it's going to just keep, you're just going to keep wiping it out over and over again. Whereas with 2Q, you'll actually, the stuff that you're using a lot will stay in the cache. Yeah, I'll have to do a talk sometime just on how the ZFS one works with the 4 lists. This one is kind of that's 2.5 lists or whatever. But
you'll definitely want to read this though. It sounds like there's some
and he has a link to the actual paper,
which
is from 1994, but describes the system for actually.
It's still relevant today.
I'm sure what they considered a very large data set wasn't quite the same thing back then.
Quite the same back then.
But, research is research. And he's suggesting a name of 2Q, TU-Q. Because those are his initials. That is cool. But it's still 2Q, the original name, right? That's I think that was pretty funny.
Very nice, Ted. Cool. Okay, well, next up in the roundup, BSD Talk. Episode 244 is out. So BSD Talk is a podcast done by Will Bachman. Been around a long time now. We want to mention that they interviewed Ken Moore, the developer of the BSD desktop environment. That's my brother, by the way, for those who don't know. So they discuss the history of development, differences between it and other desktop environments, and lots of topics. And if you're more of a visual person and want to actually see what he's talking about, you don't have to fear because we're going to be doing that next week. So we're going to have Ken on next week and then do a virtual walkthrough Illumina and its applications. So we'll have that to show off next week. That should be a lot of fun. So stay tuned for that. Well, cool. Well, that's end of our roundup for the week. We'll be back in just a moment with feedback and questions. We're back. It's time to do some feedback and questions from you guys in the audience. By the way. Yes, thank you. Some good questions this week. So we have from Grislane, the first question, asking about latest version. So he says, hello there. Happy to see a show that's not only Linux for a change. He said, I was wanting to test all my machines to see if they have the latest FreeBSD version installed. He wondered if there was something like CMS or API he could use to ask FreeBSD which versions exist, their last version number, and max support date for it. So he's saying, on some CMSs like WordPress and Drupal, you can make an API call to their site to get a list of the versions and know if yours is up to date. This problem should have been an issue for longer in the OS field, so I guess there is a system to ask freebsd.org the version and the status, but I cannot find any resources on this. He said he's trying not to parse the information on FreeBSD releases with awk said whatever to get the information, because that would be a little ugly. So we just talked about this, Alan. You know, I'm not sure there is one at the moment.
It kind of depends what degree of granularity you want too, right? Like there's FreeBSD 9.3 came out, but then there's like 9.3, P1, P2, etc. And so FreeBSD update handles changes within the version you're in. So if you have 9.3, you can run FreeBSD update and it'll pull down the latest P1, 2, 3, all the patches or whatever it needs. And it also warns you when the version you're using is reaching towards its end of life. So that must be defined somewhere.
Sure. Yeah, I'm sure he gets that. Well, wait. No. I run a FreeBSD update server. So you define that on the server ahead of time. Yeah, and a text file on the FreeBSD update builder.
So that's just manually copied off the... Yeah, the security team maintains a list, but yeah, we might have to see about putting that in a more machine-readable form. For the end-of-life dates.
That'll be something we'll see if we can pass along and maybe have that happen.
The other thing is there's the FreeBSD-announce mailing list, which only has no traffic other than, there's a new version or whatever. And then there's also a security announcement mailing list that only gets security updates. And those are low-traffic mailing lists you can be on to make sure you find out when there's newer versions. But as far as tracking, a specific version, the FreeBSD update tool with its cron setup will do mostly what you're looking for.
Okay. Well, cool. Hopefully we answered your question there. And if we have any more info on that in the future, of course, we will pass that along.
So next question, Reynold writes in about package ng. He says, hello, BSD Now. He's currently running DragonFly FreeBSD and FreeBSD 10 and running a bunch of applications.
He says thanks to the show, by the way.
He says the one thing he's having trouble with is when he does package install Vim and it downloads VI and installs it, he's finding there's a lot of dependencies pulling in and he wouldn't like there to be quite so many. So his question is, how can he control those? Well, they're set on the server side, so you can't really control them. In that specific case, there's actually a Vim-Lite, Lite, that doesn't have all the Xorg dependencies. It doesn't include an X version of Vim, GVim.
Oh, GVim.
And so that will definitely reduce the size. Other than that, you have to either build from ports or run your own Poudriere and build your own package set. They're working on improving that somewhat, making some of the optional dependencies be what's called a sub-package. So things like, do I want the documentation or not? It can be split off in a separate package that is optionally installed after. That will improve that. And was it something else they were doing? The just better interaction with package when you do compile things from the ports tree. So when you package upgrade, it'll know you got your version of Vim from the ports tree because you deselected a bunch of the default options. And so it'll know to actually go and recompile your version of Vim from the ports tree for you instead of pulling down from the package repo or just not updating it, because neither of those would be what you actually want. So in that particular case, Vim Lite is all you're looking for. And a lot of ports that are very heavy will have a lighter option like that.
Yeah, for a good majority of them. Okay. So next up is from Van. He has a pfSense story. He says, first, I can't begin to tell you how helpful your show and tutorials have been. After almost 15 years with BSD, mostly free, he says, it wasn't until the tutorial I felt brave enough to track OpenBSD current. Now, if only you could write a tutorial on convincing the OpenBSD devs to write a device driver for esoteric wireless cards from a company that has annoyed them by not releasing documentation for its devices. He says, but I digress. I don't know if we can change that. But he said he just wanted to throw his 2 cents in on backing up configs, not just data, and not to ignore boxes which don't hold data. He said he was replacing a switch, and he inadvertently brushed the power button on his company's box running pfSense. Just a tap, but enough to initiate an ACPI shutdown. No problem, he thought. I'll let it shut down clean, and I'll fire it back up when it powers off. Well, no, apparently it wound up with some corruption on the disk, including the kernel, which became rather apparent after it refused to boot. While not an overly complex thing to recreate, he says, I have a lot of client certificates for VPN access, and reissuing those would be challenging, especially on a Friday afternoon going into a holiday weekend. Ouch. So he said booting off the install media or attempting to rescue the config.xml failed with a nasty read error message, 2 or 10, he can't remember, but either way. He says he was, however, able to bring up the interfaces to the point where he could talk on the network, and after some poking around, he found a CF-conf backup and all the backup configs in it. He SFTP'd them off and laid down a fresh install. Once back up, he took a quick trip over to the diagnostics backup and restore and restored the newest, which he's actually guessing since it was the largest and since the timestamps reflected the upload time, not the file creation time. Whoops, all back up and running. So he said, lesson number one, all this would have been much easier if I had manually backed up config.xml on another box. And don't forget the golden rule of no Friday hardware changes.
Yeah.
Keep up the good work, man.
That's the advantage of using a config management system like Puppet or something, is that all your configs are easy to recreate when you have them centralized. But yes,
sure.
Sometimes backing up the configs is more important than the data. Yeah,
definitely. Yeah, in a case like this, for sure. I know.
Well, when he started reading it, I thought his problem is that he didn't think to back up the config of the switch, and he lost that. But yeah, the pfSense, that's like you said, the config wasn't that big of a deal, but all his VPN keys would have really been put him in a bind trying to recreate all those.
Yeah, that would have sucked. Well, cool. Well, we're glad you're at least able to get it up and working. Hopefully, it didn't eat too much.
But
of
yes,
your
you
Friday
definitely need to back that up. And I guess that brings up the topic we talked about the other week. Is seems like somebody needs to write a nice tarsnap plugin for pfSense that will back up your config and your VPN keys and certificates and stuff to your tarsnap, because that's only going to be a couple of kilobytes.
Definitely.
It's not going to cost anything really, and your $5 you deposit there will last you all year, and it means that you never have to sweat about your pfSense config.
Definitely. Okay. Well, next up is Sean. He's asking about SSH accounts. So he says, hello, is it possible to create a user, say Alan Chris, that can only log in via SU, Alan Chris, but not via SSH? So he says, I know you can set user SBIN no login, but the SU-Alan Chris indicates this account is not available. He said the reason is to create a test user account without the need to have yet another password to keep track of and password to rotate, etc. Do you have a suggestion for this? And I think you replied to this
I didn't for this one.
Show, right, Alan?
I did for the other one.
Or Tita did? Okay. But yeah, about setting up SSHD with a list of users.
Yeah, there's match rules that you can put in your SSHD underscore config that say, for users that match this criteria, do this to them. And you can do things like stop them from being able to log in.
Yeah, that would probably be the preferred way to do it. I'm not sure of another way to do it with the password system.
With Su, I know you can do it with sudo. I'm pretty sure you can do it with Su, where you set their shell to user SBIN no login, but in the Su command, you specify to actually give them a regular shell, and then you can get in as that user. But it depends. Generally, what I've seen is people want to do not quite the same. There are some, like in ports, I think there's one called RSSH, which is a restricted shell. And the general idea there is I don't want somebody to be able to SSH in and get a shell, but I need them to be able to SFTP in to copy a file or use SFTP or SCP or rsync. Right, so it's like, here's the 4 things they can do, and they're not allowed to do anything else. Yeah.
And that's it. Yep. Well, TJ, our producer, was telling us too. Yeah, you just basically need to deny users Chris Allen in your SSHD config file.
So in your config file, you make a list of users that you don't want to be able to SSH in. And problem solved.
That should take care of it for you. Cool. Okay, next up is from Stefan. I'll let you read this.
So he's asking about pfSense and Realtek. He says, first off, great show. He's been a listener since episode 1, and he has a little history to share and some insight. So he has one of the Socris firewalls, the 6501, and it died about a week ago. So he went out and bought an upgraded box to run pfSense on, and he settled on the NetGate, which is PC Engine's APU 1C4. However, after this firewall was deployed, I didn't think much of it, and things seemed to work. Now, the following days, he's having some enormous latencies in the range of 700, 800 milliseconds on every request. So he called the ISP, and they asked me to bypass the firewall, and then I got a perfectly fine connection back down to 20 milliseconds. So he plugged the WAN cable back into the firewall, and then it suddenly worked perfectly. He says, could this be a problem with the NIC in the Realtek, and how can you possibly solve this? He's using pfSense 2.1.4, which is based on FreeBSD 8.3. He says he doesn't want to go unplugging his firewall every 2 days, but he says he remembers me specifically mentioning something along the lines of similar. I used to have a problem with the old VIA Rhine NICs with too many of them sharing the same IRQ or something, where I had to like if down, if up them once a week or something, but that's not fun. Really, you'd have to diagnose the issue a little bit more and see what caused it. If you just leave it, does it happen a second time? If not, maybe it was a fluke, who knows? Sure. But
maybe it was a one-time quirk or something.
There's a bunch of different netstat commands you could look at to see what's happening. It is possible the delay is actually caused by the pfSense being out of memory and delaying allocating the mbuff or something like that. But there's lots of statistic counters built into FreeBSD that will make it possible for you to see what is going on. So check out the man page for netstat and look at the statistics it can spit out and see if you notice anything that seems to suggest what's going on. Other than that, I don't have enough information to look yet.
Yeah, without any other details, it'd be hard for us to, guesstimate.
That is
what
why
it was.
I generally preferred the Intel NICs over the Realtek ones, but the Realtek ones usually work pretty good. What most people told me anyway. I haven't had any in a while.
Okay. Sure. All right, fantastic. Well, that's the end of our feedback and questions for the week. So, of course, as we're wrapping up the show, we want to mention that all tutorials will be posted in their entirety at bsdnow.tv. We want to give a huge thank you to our viewer, Toby, for writing this week's tutorial as well. Thank you, Toby.
Not something any of us had any experience with, so that was very helpful.
Very helpful. And of course, for future episodes, send your questions, comments, show ideas, topics, or stories you want mentioned on the show to feedback@bsdnow.tv. That's the only place we monitor, so please try and send it there so we see it. Also, you can watch live Wednesdays at 2 p.m. Eastern, 1800 UTC. So if you want to see what we're doing, like today, for example, we recorded a couple interviews.
If you watched today, you could have seen the Adrian Chad interview earlier than everyone else.
Yeah, it's a sneak preview of what's coming in a future episode. So there's a good incentive for you guys to watch live. And of course, we got to mention something about the 1 year anniversary. Is that what
this is episode 53, and we've never missed a week. So that means this is the beginning of year 2 of BSD Now.
Woo!
Yes,
we've made it. Well, I was talking to my wife about this last night. It's like we did a whole year, but like if you were a TV show, you'd do what, 20 episodes, 15 episodes or something. So we're technically like 4 seasons in now at this point. This is pretty cool.
But the craziest thing is that we've never had to take a week off. I don't know how we've managed that, but we have.
And we've had to do pre-recorded episodes, like when we were going to be out of town or flying or whatever.
We've managed it from my other podcasts as well, and we're on episode like 175 this week.
Dang. But yay, congratulations, BSD Now. We hit the 1 year mark, and we're looking forward to another good year. If you guys have any suggestions or
we've been doing this for a year. We're kind of running out of ideas.
Yeah, but if there's something you would like to see on the show that would make it more entertaining for you, stuff you're interested in, particular topics, please let us know so we can, guests that you'd like us to interview, or if you're a potential guest.
People generally don't volunteer to be interviewed on the show. We have to go and chase them down.
But you can volunteer somebody else that we can go chase
especially
down.
if you can tell us what you would like them to talk about. Because oftentimes, I don't know what I would talk about. We had to pester Drew for an hour, and then she still said no, and then later she thought of something. So yes,
no, we did it. It was a great interview.
Or even Adrian, I guess, who we interviewed today for a future episode. It's like, he's doing all this cool receive scaling stuff, and it's like, but that's only interesting if you're really into 40 gigabit NICs. So it's like, I guess talk about something that you can actually play with today, not something that'll not even committed yet.
So again, it was a great year. Looking forward to the next upcoming year, and in a few weeks we'll be out at Euro, so that'll be fun. Come back with a whole new slew of interviews, I'm sure. But it was great. So thank you guys so much for being with us on the 1 year anniversary show this week. Really appreciate having you here and watching. Hammer is a 64-bit file system developed by Matthew Dillon for the DragonFly BSD project. Similarly to ZFS, Hammer was designed to be a next-gen file system to add new storage features to Unix-based operating systems that were previously limited to UFS or FFS. Hammer has a maximum storage capacity of 1 exabyte, that's basically really big, or more than 1,000,000 terabytes. It contains several features that provide data integrity, resistance against crashes, and fine-grained backup controls that rival ZFS. Currently, Hammer is limited to DragonFly BSD, and that OS is the only way to really explore the file system. In current implementations, Hammer can only be deployed to at most 256 devices. You can download DragonFly BSD by fetching a bzip2 compressed ISO from one of the mirrors. Unlike ZFS, Hammer does not assert control over the underlying hardware, so you can use Hammer on top of hardware or software RAID without trouble. It is designed for large drives, so a device of at least 50 gigs in size is suggested for your installation. We'll begin with an existing DragonFly installation, then add a new storage device and configure it with a Hammer file system, and then go through and explain some of the features and caveats. And take it away, Alan.
So this week's tutorial is on Hammer FS, an advanced file system that's quite interesting. While it doesn't solve exactly the same problems as ZFS, it has some interesting advantages of its own. So we're going to walk through some of the basic administrative tasks of using Hammer FS. The first one of these is obviously to create a Hammer FS. So we're going to find the disk. So I've created this SATA disk in VirtualBox that's 100 gigabytes, and we see that DragonFly tells us the serial number. Very much like FreeBSD's disk ID system, you can use that as the label for the disk. Right, so if we look under dev serial number, we can see our disk. So we'll do newfs underscore hammer. We'll call it BSD Now. And dev serial number VB5. There we go. And this will create our a Hammer file system of 100 gigabytes. We can see it sets up a free space map, and now it's creating the undo map, which is how it tracks. They're kind of like per file snapshots. It's a very interesting feature, using the transaction groups to be able to actually step back in time and keep history on a file. As it notes here when you create it up, please remember that you have to manually set up a cron job to prune and reblock the file system regularly. By default, the system automatically runs the Hammer cleanup command once each night. However, you can enable or you can disable that by using periodic.conf. You should also read the Hammer command line man page and the Hammer file system man page. But anyway, now to actually do some stuff. So first we'll make a new directory. We'll call it /data. And then we'll use mount Hammer to mount our device on /data. Now when we look at our mount, we can see that BSD Now, the Hammer FS, is mounted on /data. And we can see that we have 99 out of our 100 gigs free. Now if we want to put that in our FS tab, put it at the bottom here, dev serial number, blah, on /data, it's a Hammer. Rewrite 1, 1. Well, it says if you provide multiple devices to the newfs Hammer command, Hammer will combine these into a single Hammer file system, similar to RAID 0 or striping, and that provides no redundancy. It's similar to like old concatenated disk driver. Right? It doesn't provide you any data resiliency against hardware failure, and it does not give you mirroring or make redundant copies of your data. If you need those, then you should run Hammer FS on top of an existing RAID solution. Similar to ZFS datasets, you can also create a Hammer pseudo file systems. Right? So Hammer is, now that it's up and running, we can actually start playing with it. So we will create our first, or we'll look at the existing stuff. So we'll run the Hammer command and we'll look at pseudo file systems status on /data. And we see that there's the root pseudo file system /data, and we see the transaction ID, the label, when last time it was pruned, or the minimum time that it spent pruning it. And it's currently operating in master mode. One of the other interesting things about Hammer FS is the replication stuff. So now it's recommended that when you create pseudo file systems, you put them in a subdirectory so it's easier to tell which ones are pseudo file systems and which ones are just directories under existing file systems. So we'll create /data/pfs, and then we'll do hammer create a pfs master on data pfs my files. So now when we do pfs status, we see now we have this system. We're going to see that the started at a different beginning transaction ID, and it has no label. Now we can mount it, right? So, or we can put it in a regular place, kind of like a ZFS dataset. So we'll actually use the nullfs system to mount data pfs my files to just data my files. Now when we mount, we see that BSD Now is mounted on /data, and our first pseudo file system is mounted on data my files. And you can do the same thing to add this to your FS tab. So now, if we go to /data/my files, and we can echo hello world to a text file, and we can see there's our text file. But now, if we write a bunch of zeros, file.dat, you see that file as well. One of the interesting things that you can do with HammerFS is what are called mirrors. It's kind of like ZFS replication, but different. Importantly, there's two different modes. The first mode is mirror copy. So, right, we'll do that. Hammer, we'll do a mirror copy of data pfs my files to data pfs my backup. And this will basically make a copy of the file system. So it's copying all the data to a second file system, right? So this is more like ZFS send than creating a clone. So let's take a second while it copies. There we go. And now if we look at that directory, we can see there's the files. The other interesting one that I kind of wish ZFS had is the mirror stream. This is like ZFS send, except for it doesn't stop. It keeps transferring your data constantly. Right, so if you do hammer mirror stream of data pfs my files to data pfs my backup and stick that in the background, that will now run continuously. So if we create a new file, this is a new file to data my files new file. Make sure that gets written. And now if we look under my backup, give it a second to replicate. And there's the file. That's really cool, and I wish ZFS could do that. Other interesting thing you can do is file history. So if we go back to the my file directory and say we change the message in our hello world file. Now if we do hammer history on that file, we can see that we have two different versions of that file from two different times. So now we can do undo, and we can see that originally it said hello world period, now it says hello world exclamation mark. Or we could do undo and save the copy to hello world.txt.original. Now when we look at that, we've restored the original file. So now we have both. It even works if someone deletes it, right? And if we delete that new file, we can see that it's now gone. But if we undo new file.txt, we can see the content is still there on the disk. You can also do a diff, right? If we do undo -d on hello world.txt, we can get a unified diff of the changes of the files. This also works if we do a whole bunch of them at once. So I'm just gonna do this. So now I've changed the content of the file a bunch of times in a row. And now when I do undo on that, we can see all the different versions. Or we can do a diff based on specific versions. So I'll take, say, that one and what is currently in the file, and I get a diff of just between those two specific versions. Now, this is different than snapshots, right? This is file history based on the transaction groups. We can also do snapshots. So if we do hammer snap my files and call it snapshot1, we can see there's a snapshot with the date and the transaction ID. So now if we create data my files back to an important directory and stick important user data here and throw that in that directory, then we can snapshot just that directory. They're a little different than ZFS snapshots, right? They're considered live. They don't need special instructions to access their content. You store the data from a snapshot by copying it back to the location. However, side note, hammer snapshot set the file's modified and access times to be the creation time of the snapshot. So if you're restoring from a snapshot, it's not going to restore the original modified times of the files, which can cause interesting side effects if you weren't expecting that. So if we go to that directory and do stat on file.txt, we can see when it was created. But if we do snap there, we can see that it's slightly different. So if we go back to our main data set and delete our file. Now the other interesting thing is it has a special command, cpdupe, which is kind of similar to the extra flag for CP that ButterFS has on Linux, but basically allows us to copy all the files from the snapshot back without actually recopying data that didn't need to be replaced. So it copies, but while skipping duplicates. Now, obviously, with keeping all this file history and your snapshots, you're going to run out of space eventually. That's why there's the hammer cleanup command, which goes through and based on the policies you define, create new snapshots and remove old snapshots, prune any blocks that don't need anymore, rebalance your blocks so that if you have unbalanced lines, they're balanced again, reblocking, which is kind of a defragmentation, and then recopy, which is a full defragmentation where it actually just copies all the data over again, kind of like a log structured file system. By default, DragonFly BSD creates daily snapshots of your Hammer file system and stores them for 60 days. However, you can change that. If we run hammer vi config, we can see that snapshots are created once a day and kept for 60 days. The rest of them work a little bit differently. Each of these operations is run once a day, and maximum is allowed to run for 5 minutes. So you can modify that so you can define how long you want your maintenance window to be. Right? You want prune is only 5 minutes, rebalance 5 minutes or whatever. And then if you need a longer one, you can do it manually, or you can modify these times to make them longer to allow more work to get done. So you can see we do a short defragmentation once a day and a big one once every 30 days. So we can change this a little bit and say we only want to keep our snapshots for 7 days. Obviously, you should read the Hammer man page to learn more about these settings and how to set them up. We can also run each operation manually. So if we do Hammer and do a reblock on data my files, and we can specify the percent we want to defragment. So we'll say, defragment until it's at least 80% good, and it won't take as long as doing the full thing. Or we can specify 100 and make it do the whole thing. And as you can see, the first time it didn't actually reblock anything, but the second time it actually did. You can also do Hammer info on Hammer FS, and you can see lots of information, including information about the block usage, space information, fragmentation, all that interesting stuff. And you can see you have your masters and your slaves and so on. You can also do Hammer history on a file and see how many different versions there were of that file. There's also a special prune everything command, and this will get rid of everything to free up more space. And then now, if we look at the history on, say, this file, you'll see that we no longer have all the different versions of that file. So both the Hammer reblock and the Hammer prune everything apply to per PFS basis. So you can choose to do this only on one of your pseudo file systems, kind of like ZFS datasets. So you can selectively reblock or prune one pseudo file system and reclaim space that can be used by other pseudo file systems. So it allows you to keep snapshots for a long time on one PFS and prune them more quickly on another. If you have temporary data over here, you want to, or if it's log files and you don't need to keep the snapshots as long, you can do that. There are many other powerful commands you can use to manage your file system history, possibly destroying it, and being mindful of how to use them. So definitely recommend that you read the man page. So in conclusion, Hammer is a very sophisticated storage mechanism, and it provides functionality similar in some ways to ZFS, but different in a bunch of other ways. It has a number of very interesting advantages, and some unique features that aren't found anywhere else. It combines support for large file systems with data integrity, crash resilience, snapshotting, powerful mirroring features, file history, recovery tools, and oftentimes the snapshotting and the file history are almost kind of like source code control, right? When you can diff the changes to a file every 30 seconds, it's kind of handy for working with your different files. So anyway, we definitely recommend you check out some of the more interesting stuff. There's a bunch of links in the tutorial doc on the website, so definitely check it out. Thanks for watching. We'll see you next week.